Welcome to Trees and Graphs. In this lesson, we will explore two important data structures, trees and graphs. These structures are widely used in various applications and provide efficient ways to represent and manipulate relationships between entities. Let's dive in. Introduction to trees and their properties. Trees are hierarchical data structures consisting of nodes connected by edges. They have a root node at the top and child nodes branching out from the root. Each node can have 0 or more child nodes. Common types of trees. There are several common types of trees, including binary trees, binary search trees, and balanced binary search trees. Binary trees have at most 2 child nodes for each parent node. Binary search trees maintain a specific order property, where nodes in the left subtree are smaller and nodes in the right subtree are greater. Balanced binary search trees, such as AVL trees, ensure that the heights of the left and right subtrees are balanced. Traversing and manipulating trees. To traverse and manipulate trees, we use various methods such as pre-order, in-order, and post-order traversal. In pre-order traversal, we visit the root node first, followed by its left and right child nodes. In in-order traversal, we visit the left child, then the current node, and then the right child. In post-order traversal, we visit the left and right child nodes before the current node. Introduction to graphs and their properties. Graphs are versatile data structures consisting of vertices, nodes, connected by edges. They are used to represent relationships between entities. Graphs can have directed edges, where the relationship between vertices has a specific direction, or undirected edges, where the relationship is symmetrical. Edges can also have weights or costs associated with them, creating weighted graphs. Common types of graphs. There are several common types of graphs, including directed graphs, undirected graphs, and weighted graphs. Directed graphs have edges with a specific direction, representing one-way relationships. Undirected graphs have edges without any direction, indicating symmetrical relationships. Weighted graphs have edges with associated weights or costs, representing the strength or distance between vertices. Graph traversal algorithms. To traverse graphs, we use algorithms such as depth-first search, DFS, and breadth-first search, BFS. DFS explores paths as deeply as possible before backtracking, while BFS explores all vertices at the same level before moving to the next level. These algorithms help us navigate and discover relationships within graphs. Thank you for joining us in this chapter on trees and graphs. Trees provide a hierarchical structure for organizing data, while graphs capture complex relationships between entities. By understanding their properties and operations, you will be equipped to solve a wide range of problems efficiently. Remember to subscribe to our channel and press the bell icon to receive updates and notifications for future lessons and content. Happy learning!